One application that we have for working with the prime factorization of a number is being able to find greatest common divisors with some other value, where the greatest common divisor is the largest shared factor. In some other places, resources, you'll see it called the HCF instead of the GCD, where that stands for highest common factor. It's not a guaranteed notation, but GCD, greatest common divisor, is what I'm most used to. Where for this, there are a few steps you can follow in order to be able to get the greatest common divisor of some group of numbers, where we're going to focus on 2 for the most part here. So what you would do is write the prime factorization of each number, then select each prime factor with the smallest exponent that is common to each in the factorizations, then form the product of the numbers from step 2, where that product will be your GCD, where in particular we can call numbers relatively prime if their greatest common divisor is 1. So for example, 2 and 33 are relative primes. Really, any 2 primes would have to be relative primes, and then any odd number would be relatively prime with 2, so 2 is not the most interesting, but it should be clear and indicative of what that sort of thing sounds like. Anyway, let's get one example here of how we can use greatest common divisors. So for this, we have that in an intramural league, you must divide 40 men and 24 women into all female and all male teams of equal size, and we need to determine what the largest size such a team can be is. So we need to figure out how big we can make our teams, and we want them to be as big as possible. If we're going to be very lazy here, we might just look at a factor that is shared between them, like 4, and say that's good enough. But we want to be specific. We want to get the most we possibly can without making the teams uneven. So that means we need the greatest common divisor of 24 and 40. Where in order to be able to get that greatest common divisor, the place to start is the prime factorization. So to think about that, we're going to get our factor trees again, where you can split 40 into 10 and 4, then 5, 2, 2, 2, and then 24, you can split that however you want to. We're going to go with 24 into 2, 12, 2, 6, 2, 3 to get factorizations in this case. I'm not sure exactly where I'm going to put that, so I'm going to write it here, I suppose. 40 can be written as 2 cubed times 5, and 24 can be written as 2 cubed times 3. Where looking at this, in the second step of our process, we need to identify the largest shared exponents here. In this case, 5 and 3 aren't shared, so you don't have to worry about them. And then in here, we have 3 2's each. These are our shared factors, and as a result, if we want to get our greatest common divisor, our GCD, that would end up being 2 cubed, or 8. So if you ever need to get greatest common divisors, you just take the factorization, identify the most you can pull out of that factorization, multiply it out, and you get that. Where in this case, if we want to talk about it in terms of our application that we started with, that would mean you want teams of size 8 to maximize team size, so we would have 3 teams of 8 women and 5 teams of 8 men. And kind of the other side of what we can do with this is our other application with factorizations, which is called the least common multiple, and that's what we'll finish with.